Welcome to this explainer. Today we're investigating an absolute astronomical paradox. We're pointing our virtual lens at a deep sky object that's literally enshrined in one of the world's most famous observation catalogs. But here's the wild part. Modern science is starting to realize it barely even exists. It's kind of like a cosmic ghost story playing out right in our own galactic backyard.
So let's dive right into this mystery. We're focusing on a really subtle grouping of stars tucked away in the sparkling, super-rich star fields of the Vulpecula constellation. Now, stargazers have been pointing their scopes at this exact spot for generations, right? But the actual identity of this object, Caldwell 37, or NGC 6885 if you prefer the technical name, is a huge question mark that modern astronomy is still actively debating. Like, is it a real, true cluster, or just a beautiful trick of the eye? We humans, we naturally want to put everything we see into neat little boxes. But as you'll see, the universe doesn't always play along.
Just to get our bearings here, this whole ambiguous grouping sits roughly 1,950 light-years away from Earth, and it's centered really tightly around this prominent foreground star called 20 Vulpecula. It's hanging out in an incredibly dense, crowded region of the Milky Way, actually not too far from the famous Dumbbell Nebula, Messier 27. And you know what? It's exactly that crazy stellar density that creates the whole problem we're unpacking today. Because when you have literally thousands of stars jam-packed into a single line of sight, trying to figure out which ones actually physically belong together, well, it becomes a monumental challenge. Now, by almost any modern standard of deep sky observing, this is an incredibly odd choice to feature in a famous catalog. It totally subverts our expectations. I mean, Caldwell 37 has no blazing emission nebula. There's no violent supernova remnant, no black hole devouring matter, no glittering spiral arms. None of that. It's entirely devoid of the usual cosmic fireworks. Usually, when an object gets its very own special designation, we're expecting some dramatic, mind-blowing astrophysics, right? But here, it's just a remarkably quiet, really subtle gathering of light.
So how on earth did it end up on our maps in the first place? Well, ever since William Herschel discovered it way back in 1784, visual observers have really struggled to define its borders. I mean, all throughout the 19th century, astronomers were constantly confusing its boundaries with a neighboring object, NGC 6882. Some catalogs merged the two together, others kept them completely separate, but hey, this wasn't sloppy science. Early observers were just completely reliant on subjective star patterns and apparent brightness. And let's face it, that easily tricks the human eye. The sky is under absolutely no obligation to cooperate with our desire for neat boundaries.
And honestly, this whole situation brilliantly illustrates the massive paradigm shift in how we actually understand the universe today. We've moved away from early visual astronomy, where we just asked, hey, do these stars look like they're grouped together, and stepped into the era of modern astronomy. Today, we demand proof. We want to know, do these stars actually move together? Are they at the exact same distance? Are they physically bound by gravity? Or are they just, photobombing each other from hundreds of light years apart? It's literally the difference between looking at a flat painting and a dynamic 3D sculpture.
Which brings us to a real game changer, the Gaia mission. The European Space Agency's Gaia spacecraft basically handed us the ultimate CSI toolkit for this starry mystery. It totally revolutionized astronomy by measuring stellar parallaxes and proper motions. What that means is, it tracked the exact 3D distances and the teeny-tiny movements of stars across the sky with just absurd precision. So instead of us just guessing from a flat image, Gaia handed us the dynamic 3D reality of the Milky Way. Think of it like finally giving humanity true depth perception, but on a galactic scale.
And when we point all that incredible Gaia data right at Caldwell 37, the results are absolutely fascinating. It turns out this object sits perfectly in a scientific gray zone. The data is kind of split right down the middle. It might be a true gravitationally bound cluster, or it could be a dissolving association of stars that are actively drifting apart. Or, get this, it might just be a total line-of-sight coincidence, where completely unrelated stars just happen to line up perfectly from our vantage point here on Earth. So it's way less of a cleanly defined object and much more of an ongoing question. It really makes us challenge the very definition of what we even consider an astronomical thing. The absolutely crucial point to understand here is that open clusters like Caldwell 37, unlike those super dense, tightly packed globular clusters, are actually incredibly fragile. They're only very loosely held together by gravity. Because of that, they're constantly getting torn apart by the relentless forces of the Milky Way itself. You've got galactic tides pulling at them. They're smashing into giant molecular clouds. Random stellar interactions are physically flinging stars away. Plus, there's just simple orbital drift scattering them over time. It is a highly hostile environment for these loose groupings. Survival is just a constant uphill battle against the mechanics of the galaxy. So what you should really take away from this is this profound sense of cosmic impermanence. Whatever original grouping was there is actively fading into statistical invisibility. Eventually, all those stars are just going to evaporate right back into the general galactic disk. Astronomically speaking, Caldwell 37 is less of a permanent destination and a lot more like a slow-motion disappearance. We are likely catching it right in its twilight, right in those late stages of it just evaporating into the background. It's a beautiful, fleeting moment in deep time, kind of like watching a puff of smoke just slowly disperse in the wind.
Which, of course, brings up a genuinely fascinating question. If this thing has no dramatic core, no violent physics happening, and it's literally actively dissolving into a trick of perspective, why on earth did the legendary astronomer Sir Patrick Moore include it in his famous Caldwell catalog? Seriously, what do we actually value when we look up at the night sky? Why dedicate precious catalog space to a dissolving ghost?
Well, the answer really lies in Moore's totally unique philosophy. See, the Caldwell catalog was never meant to just be a strict greatest hits list of extreme astrophysics. Moore actually wanted to encourage us to explore way beyond the obvious showpieces. He actively aimed to mix those spectacular astrophysical landmarks with targets that were just aesthetically pleasing. Caldwell 37 made the cut simply because it's bright, it's accessible, it's visually lovely, and it sits in a stunningly rich region of the galaxy. It's a great reminder that sometimes the simple, quiet beauty of the night sky is reason enough to point your telescope upward.
So how should you actually go about looking at it? Well, if you want to experience this object the right way, step one is absolutely crucial. You've got to ditch the high magnification. Using high power is just going to expose the awkward reality that there's no commanding geometry or obvious central core there. Instead, grab a pair of binoculars, or maybe a small refractor or a rich field telescope, and just prepare to observe the galactic disk itself. You literally have to step back. If you zoom in way too close, you lose the forest for the trees, or, well, the cluster for the stars. Because when you view it at low magnification, especially under dark skies, the whole experience is completely transformed. This ambiguous little cluster suddenly becomes this breathtaking, totally immersive experience. Your eye just starts wandering through this incredible tapestry of layered star clouds, picking up subtle color contrasts and tracing those wandering chains of foreground giants like our old friend 20 Vulpeculae. You actually stop observing a distinct object, and you start experiencing the overlapping, three-dimensional depth of the Milky Way itself. And that shift in perspective, that is Caldwell 37's true value.
Interestingly enough, we run into this amazing paradox when we try to actually photograph it. You'd think a nice, long exposure would clear things up, right? Well, nope. Deep astrophotography actually reproduces the exact same scientific ambiguity we've been talking about. The deeper your exposure, the more enormous that stellar density becomes. It makes it almost impossible to visually separate the cluster members from the incredibly crowded Milky Way background. The object literally dissolves under our scrutiny. The harder we try to capture its borders with modern imaging, the more it just slips right through our fingers, blending completely seamlessly into the vastness behind it. And honestly, this entire explainer serves as such a beautiful reminder. Modern deep sky culture often completely prioritizes violence and spectacle, like black holes and massive exploding stars. But the universe, it isn't just a collection of cleanly defined permanent objects. So many beautiful things out there are transitional. They're these dissolving structures, partly just the product of our own human pattern recognition imposed onto a crowded, magnificent sky. Astronomy isn't just about cataloging things on a list, it is the ongoing, messy, amazing process of determining what an object actually is.
And sometimes, the answer just remains beautifully unresolved. It really makes you wonder, doesn't it? If Caldwell 37 is ultimately just a trick of perspective, a slow-motion disappearance in the dense star fields of Vulpecula, what other beautifully unresolved illusions are hiding just above our heads, just waiting for us to simply change our perspective? I'll leave you with that thought to ponder the next time you step outside and look up at the night sky.